Okay. So maybe we should start looking at Malli. I don't know if anyone has any. Nate, I don't know if you had a chance to look at any of those. There's 3 articles. I mean, there was no tutorial that I found. So if you guys know of any particular tutorial, then we could try to go through that. But there are 3. The README is pretty good. So that was one option to go through. The other option was 2 other blog articles. One was, I think, the original a blog article from Metosin, who when it was announced, when Malli was announced. And then there's a recent one which says high performance schemas in Clojure scripts Malli, which has some well, it's one thing is that it's more recent, and the other thing is it's got a few examples and it's got some benchmarking as well. So those are 3 that I found that were that were potentially things that we could go through. I'm wondering if anyone has any other suggestions.
I took a brief look at the README. It's really long. I mean, but it's comprehensive. There's also like an interactive like a site, Malli.io, which is
okay.
They have a way for you to kind of interactively like play around with schemas, which is kind of neat.
Oh, I see. Yeah. Maybe we can do that in. Didn't know about that, so I didn't really try it out. But maybe we can use that in conjunction with one of the other ones, so that we can look at what they've done in one of the other things like the README or so on, and then try it out in the Malli playground.
Yeah. Yeah, I mean, I'm happy to, like, Nate, last time you asked if I wanted to drive, I'm happy to do that if you want.
That would be wonderful, especially considering my audio issues. I would say go for it.
Okay.
I would love to follow along.
Let's see, we got to share screen.
Also, I enabled multiple screen sharing in this, so hopefully that might even be a nice thing to do too. Anyway, go ahead.
Yeah, okay, cool.
What is a multiple, you mean we can share multiple screens at a time?
Oops.
Supposedly.
Oh, okay. Didn't know that.
I don't know how it works if they're side by side or if they're overlaid on top of each other, or
All right.
I did push up a commit to master on the code repo that it just had, so you can start REPL with Malli included. So if that helps, but if we can use the online one, that would be good. I don't know how amenable it would be to pasting in stuff from the README, but
yeah, we can try that too. I mean, I kind of like started up like a little just Clerk project. So I thought maybe, like we were talking about Clerk last time, I thought maybe that might be fun.
Oh, that's good.
Try to do something with Clerk and Malli together. So I mean, we could do that too. But maybe we can just start with a README and then like try some of those other things.
Sounds good.
Okay, so yeah, here's and then the online demo is just here under the list of features and presentations. So actually, before we do that, it probably makes sense to like talk about like what Malli is. So I guess it's, so they're trying to distinguish themselves from schema and spec, I guess. The key thing I think is probably the all right. So the problem with schema they're saying is serializing, deserializing schemas is non-trivial, and there's no support on branching. And then spec, like Sergey, like you were saying, I mean, it's kind of very macro focused, and I think they, there's some issues with that. I mean, in terms of, there's the old adage like data is better than functions is better than macros. Molly's kind of going all in on data orientation.
Do you know whether spec 2 is also like that?
Spec 2, I don't know much about spec 2.
Yes, they just like they fix a couple of things, but still all macros. And, like it seems like they don't even have a plan to merge it. It was like just one of the attempts that they wanted to solve some of the problem, but I guess they tried it and they don't like some parts of it, so they don't rush to bring some solutions that they don't want to maintain moving forward.
Yeah, I mean,
but I think they use it heavily for latest Clojure versions. So behind the scenes, it's heavily used. But I feel like in a beyond compiler, in the real world examples where you try to validate forms and like work with runtime data, it doesn't work that well. So I guess they're still looking for a better solution.
So yeah, let's take a look at what Malli looks like. I guess they have two syntaxes, I guess, a vector and a map syntax.
So map is something that they've added recently. It used to be only vector, and they say below that it's very alpha still.
Yeah, alpha, subject to change. Its map syntax is also called schema AST. And then here it says Y two syntaxes. And looks like parsing the vector syntax can be, I guess, can be slow. So using the schema AST can be faster. I guess you're just doing like map lookups versus having to actually parse the vector. So that's faster, I guess. But presumably there's a way to automatically transmit. I mean, like go from one to the other. It looks pretty straightforward actually, because the vector syntax just looks like a vector with the first element being the type. And the map syntax is, just has a type attribute, which indicates the type. And then the properties are inside of a properties attribute, and then children, versus the map has like a first element is type, very much like Hiccup. And then, there's an, I guess, optional second property.
Yeah, it's just right above. So it's type, properties, and children, or like type and children. You can skip properties.
Yeah. So yeah, and then
interesting that it's children like that.
Yeah, I guess Hiccup is the same way.
Oh right, it's like Hiccup.
Yeah. So like we can play around with that here. So like they have some examples of different schemas here. So this is just an empty schema. That's not very. This is an any schema. This one's probably the first like useful one, which is, although this is a little bit complex. So this one's basically like saying, this is a map where the first, X is an int, Y is an int, and it also has to conform to this this predicate, which basically the X value has to be greater than the Y value. So in this case, X value is less than the Y value. If I change this to something greater, it validates now, which is cool. Doesn't show any errors. And then like they have all this like sample values and transform schema, JSON schema, Swagger schema, inferred schema, sample values. I'm assuming the sample values are coming from some sort of like test check type generator or something like that. But yeah, so like it looks like, from this, there's a whole bunch of things that are kind of put together here, but you could probably, whoops, oh no. I'm guessing like you could just do like int by itself, and then the value of, this is true, 1 is true. But if I, say like, ABC, so it should be an int, and then the values are here, string, and it's okay.
I'd love to see a
Yeah,
Clojure.
it definitely
spec
feels like they're.
playground.
Sorry?
I'd love to see a Clojure spec playground like this.
Yeah. Yeah. This is pretty fun. I mean, actually, so like here's another one. This is like a map. This is a map. I guess this is just like metadata for the map thing. So just giving a title of user, and then there's a name attribute which is a string. There's an age attribute which is an int, has to be greater than 18. Gender is optional, and then it has to be one of these values. Email is a regular expression, I guess. I'm just trying to, I'm just trying to read these.
Oh, wow.
Yeah. And then so there's metadata about it.
Regular expression, you can generate, like give them a function to help generator to generate better values for you. And yeah, so this like pretty much
I was
always
wondering about
generate you
that.
an email. Yeah, you can customize error messages and so on.
Yeah. So if we say like, get rid of this, and it says, it's using this custom error message should be email. Things like that. And yeah, this is the generator you're talking about. So it's not a great generator, but it is a generator.
So they must be generating the data down there in sample values, right?
Oh yeah.
I mean, that can't.
Randomexample.com is in every single one of them.
So why is that?
If you change it in the spec, does it change it down there?
Yep.
Wow, that's fast.
Yeah.
Why does key have the? Why does that key have the word fmap in it?
I guess this is a function because so constantly is going to return a function that constantly returns this value.
Yeah. So gen/fmap is specifying
Like a map function.
what function is applied to what.
Because fmap is in fact the name of a function in test check.
Right.
So if you want to know how to use it, you have to check the definition in the documentation of the test check. I forgot how it works, sorry.
Okay, but just from what we see here, what do we deduce about it? Why are we using fmap? This is specifying the value for
the sample.
This is for the case where you have a complex value and you want to generate email. If you just put a string, it will generate some garbage that is not email. So you need to specify your own generator to still generate valid values.
Yeah, I mean, I guess we could put in a different function here. I don't know if fmap takes any arguments. I'm not sure. No, it doesn't. I guess this is kind of the same thing. Although, what is this? Oh, it should be email. Oh yeah, I still have to. Yeah, I don't know what. I mean, you can take a look at what test check.
Yeah, I mean, it's basically, so if you look at the other values, test check is also generating values for all the other fields. Yep. For the title and the name, but it's using its own internal generator to do it. Mm-hmm. Whereas, for email, it's like, it's asking you. So for instance, like I've used test check very lightly before. But, if effectively, like, if you want to, for instance, like restrict your search to certain values, you can write your own fmap instead of letting it, increase the search space for your test values, making your tests go much faster. Like, if you had error conditions, like, for instance, if you had only an app that had only US phone numbers, then you could have that pattern and generate like, a limited set than just every 9-digit number, something like that.
I guess my question is, if we're calling the fmap function, what is being passed to it?
Yeah, I'm trying to figure that out too, because like, I mean, if it's just a function that always, returns a constant, that's not super useful.
Right. So you could.
But you can randomize, like use gen symbol or some randomizer
Yes.
inside to create different strings. And yeah, I don't think it has anything passed.
Oh, really?
Yeah, you can read it from a resource file, and then like, from a chosen set of values, you can just pick it up.
Okay, so it doesn't need to be a pure function. It can be like a side effective function.
Yeah, I mean, it's just constantly the same, like, it's a limited set of values is all I can get at.
Okay, so all right.
So you can, return, you can, flip a coin inside and then just pick one of the two values,
Yeah, yeah, I guess so. All right, I'll just put it back to what it was. Cool. And then there's also like, I guess this is interesting too, because this is saying this is an integer that has to be greater than 18. So you can actually have like a kind of these sort of inline predicates. So presumably if I change this to 8, yeah, it's going to say it should be larger than 18.
Yeah, and it seems like, the sample values that is generating is also honoring that criteria.
Yes, yep. That's right. These are all greater than 18.
So somehow that is also plugged into like test check, and it lets you, generate values based on.
Yeah. So there's this like I guess the strings are coming from like a standard test check generator for string. Ints are coming from a standard test check generator for int, but also, like you said, it's taking into account. It seems like it's taking into account this particular predicate too.
So is the colon greater than a word that exists within Malli, or does it come from test check, or what?
I think it comes from Malli.
Malli.
Sure.
So yeah,
it's in Malli.
Malli has
a bunch of built-in ones.
Yeah.
Oh yeah,
Yeah, there you go.
Comparators, so we can
Oh,
see.
very nice. Yes. Can you find your own keywords to act as functions? I'll bet
You can define, yeah. There is a way for you to define your own functions and use them like keywords and then use them inside.
Nice.
So you can do like either a global library, there's like a README section about that, or you can do a local library inside the schema. So in properties, there's a special key where you can put definitions for your keywords, and then you can go to like custom registry.
Nice.
You can click on README at the top, and it has like the
Some error messages. Is there? Yeah, maybe in the index at the top they probably have some list of features here.
like the README at the very top right now. You can click on it, and it will navigate to the headers. So scroll a bit down, and like click on this README MD on top of Malli.
Oh, okay.
So no, to the left of it on the icon. So it has like a table of contents.
Oh, okay. I didn't know that.
Oh.
Okay.
Oh, that's cool.
All right. So what are we looking for here?
It's custom registry, the header name.
custom registry.
You can do like your own registry. So like this negative int, positive integer is something that you create as schema, and then you can use it inside your schemas. And then you can do local registries, just put in there. So like you put age, for example, and just use it in schema to define it. You use it as a definition.
Very cool. And then just pass it as this property to the validate.
Yes.
Yeah, there's some other ones I think in here also, like so we looked at user. So this one, oh yeah, you can also have like tuples. So this is basically a lat long or longitude latitude tuple with two doubles. Here's another one.
This is kind of a multi-schema, so it will dispatch based on property type, and then if it's human, then it uses the schema below to validate it. If it's other types, you can do similar to what you do with multi-methods. Just can do the same thing for schemas. And I think you can also define your own dispatch function, but I'm not sure about that.
Oh, that can. It looks like a pretty open system in that way.
Yeah.
Customizable.
Yeah, very cool. I'm just going to flip through some of the other examples so we can just take a look too. What's going on here?
That's a
Recursive
sort of
schema.
recursive, yeah. But
Nice.
Oh, so you can recursive data structures. So this is saying it's using registry, schema, registry, and then I guess this is giving it a name. Or maybe this is probably referring to what's in here.
So I guess we're giving an explicit value of the registry. Yeah. And so it has a console member
Referring to itself.
that refers to itself. Very nice.
Okay. And then, oh, here we go. Oh yeah, I think there's somewhere where they say like maps are open by default, but you can treat them as closed. So meaning like in this case, the country map. Sorry, example down here. Wait. Country has a map with name, neighbors. Oh, okay, wait, so this is saying, this is a schema, and it's defining these types in the registry, country, burger, order line, and order. And the thing that is happening here is it has an order. And this is a map, which is closed, which basically means that you can't have any attributes that aren't defined inside of this schema. So the order has lines and delivery. And if I create like a different thing here and just call it like, oops. Oh no, my computer froze. Can you guys still hear me?
Yes.
yeah.
My browser died. Oh wait, there we go. Super slow. I don't know what's going on. Maybe this is super slow. Let me pick a different one.
It might be generating the data below. If you click on order and scroll down to like the sample values that it generates, it's pretty bonkers.
Oh.
That might be slowing the browser down.
Oh yeah, yeah. All right, just probably trying to do too much. But if we take, yeah, anyway, I mean,
Yeah, so another cool thing that they do is like you can do human readable errors and explain what's going on. So yeah, like you can, for example, do a closed map and then it will generate you an error. It's not very cryptic. And then there is like a special explain thing that changes it into human readable error, which is also pretty cool.
yeah, so maybe we could try this like closed true. And so like name, age, email, and then if we added a different here, like it says disallow key toolbar because it's closed. And if I move that, then it's fine. But yeah, like I said, we could.
That's cool. I remember schemas, schematic schemas are closed by default, and it was often frustrating to make them open. But it's nice that it's really easy to change that in Malli.
And I guess we can, yeah, like I guess like this error message thing is
If you go like in the Malli README and open the section on custom error messages, you can see that it's like very powerful in what you can do.
okay, so we have the error message key, which is what we're looking at, and there's also an error function. This error function look like? So this takes in I guess this takes in the object.
It has like schema definition and value.
Oh, okay. So this is the schema. First argument is the schema, and the second one's the value.
It's like it's a map, I think. I don't remember.
The first argument is a map that contains a value field, and we're looking to use that value field as a parameter.
Yeah.
That's the deconstruction here.
Okay.
So then when we say str value, the value is available to us as though it were an independent parameter.
What's the second parameter here?
Anything.
So who's calling the error function? I guess like what are the when you pass an error function? I mean, I guess maybe they describe somewhere what the error function signature needs to look like. Or do they?
Yeah.
It gets called when you do validate. So it will get called if you have. I think it's if you do like this humanized message, that will call this error function.
Okay. Yeah, it's a very long README. I'm sure it's documented somewhere. Let's see what error functions. Error messages. Maybe. Oh no, that's right. It's just above. It's outside.
I guess this is what we'll get in this error function. This commented schema value errors, and then you can work with those errors.
Oh, okay. I see. Like this kind of thing.
Yeah.
A path in schema value. So this would be the value.
So value is like what you actually was passed to validation. So
right.
Your object, and then schema is like your original schema, pretty much what you had there. And then errors is whatever they detect as errors, and you can use it to build a custom message.
Cool, cool. All right, let's see. Is there anything else interesting in here? What were we looking at for? I think border. We're looking at this. Pets is not loading. Oh, there we go. Yeah, this is interesting too. So like for some of the simpler ones in the beginning, it just straight up just called, this is a map schema, or even if we just say like string, this is also interpreted as a schema. But in the later ones here, we're actually using the schema key here with the registry thing. So it's more complex things here. So we do this, so we can specify this different schemas and then we put them down here. If you have a, yeah, these are references, I guess, to these schemas inside the registry.
Yeah, so that's a registry, that like local schema registry, that you can define your own arguments, like the keywords or strings. And then you can refer in a bigger schema. So like it's a multi-schema dispatching by type, and then it can do cat or dog.
We're looking at registry also for like the custom, this custom registry here.
Yeah, so it's like a local registry case. Like
Okay.
So you can either define a global one or like local one, depends on what is more convenient for you.
Doing it this way is one option, and then doing it this way, like with the schema and then the registry thing inside is another option. Okay, that's cool.
So could you, yeah, that is a good thing to point out. I didn't realize that schema was at the top like that. That it's like a type. And so that's just like a way you have to put something in the type area. Like a sort of map up there.
Yeah, I guess so. So there's a special, I mean, like the first key is going to determine whether, like in some cases it's like a, it's like an and or like a map or whatever. But in this kind of case, it's schema, which has a particular semantics.
So you have like type, property, and then children, and children is like must be a schema.
Right. And this is interesting too, because like, here's an integer and you can give it a minimum value. Presumably there's maximum values, default values. You can specify them here as well, which is really neat. So if we say type.
Yeah, all of the like colon schema, colon multi, colon greater than, they're all schemas. They all validate something. Like I bet the schema is not too picky. Like it doesn't have to necessarily validate as failing, but that's the way that it's generic. It's generic. If you look in the README, there's like built-in base schemas or core schemas or whatever, and schema is one of those. So there's a bit of a self-referential loop there.
Yeah.
So this schema is merging a pet with dog, so you can see like the dog is merged. So you need type, name, and pack size. Yeah. So you can even merge schemas, which is pretty cool as well.
Yeah, and then I can say it should be at least 0 because it's a minimum value. 7, that's really nice. And then default value.
You see like it generates you a normal human readable error. By default should be between 0 and 7.
Yeah, it's really nice.
Yeah, they put a lot of care into this library.
Yeah. So
and there's a lot of flexibility. I didn't realize the flexibility in being able to compose and differentiate like this, like the picking which schema to validate, like the dispatching built in. Like I figured that I would have to do that in my own code, but that's pretty amazing.
Yeah, it's really nice.
It means you can co-locate things that are similar, and I can see the use for that. A big use.
Yeah, definitely. It's really.
So what happens when you like put a dispatch type outside of cat and dog? Like what happens when you put some, mouse in there? Sit there complaining? Oh, nice. Like a human readable form would be nice, not one of like cat or dog.
Yeah, that's true. I bet you could also do
I
like.
bet you can put a custom error message in there somewhere.
That's true. Maybe you can just say, what was it? Error message?
Oh, I forgot.
Maybe it was keyword
Forgot what.
error and then slash message.
Yeah. There.
Yeah.
Ah, cool. There you
That's
go.
nice. That's
So you
right.
can do error function and then do a function that will say whatever you need.
Yeah, that's nice. That's really nice. Yeah. It's much better than I don't know what an enumerated value is. It should be one off. So, cool.
Yeah.
I think it will be like if you do enum type, it will say it should be one of blah blah blah. So with all enum values, but because it's a dispatch function, it doesn't know like what all the possible dispatch values.
Right.
And you can do them dynamically probably in some cases. So just
Yeah, I think the error FN one, the one that you get a function and you pull out the value. I bet the schema is one of the other things you can pull out. And if the schema is one of the things you can pull out, I bet you can get the registry. I mean, I bet you could reach into the registry.
So do like just X and like return X, like string of X. Let's see what returns from the value.
I like the error message.
Is this the right key? I don't know if this is the right key.
Yeah, it's error function.
Error function. Oh, error function takes these things, right? So,
It takes two arguments.
It's a quoted string.
Yeah.
It's a quoted form. I think outside the FM, before the FM.
Right.
Oh, sorry. Yep. Oh, so it's serializable. That's cool. This doesn't.
Does that say that it doesn't know whether it's valid or not?
Yeah, let's see if I can. Let's just copy this
Yeah.
function entirely. What is it? Where's the? So this is the error function here.
I think you only need to quote it if you want to serialize schema. Otherwise, it doesn't care.
Oh, really? Okay.
And I also think if you quote it, then you need the SCI library as dependence.
Oh, okay. So actually, yeah, that worked fine. If I don't quote it, yeah. So then it gives us a first element is going to be. Actually, let's this one. Type schema error.
So the error function gets past the error to it.
Right, and then let's see what.
That's error value and
the second thing is the schema. I guess this type registry object.
probably something internal.
Yeah. Okay. This is probably. This is the first one, which is. Oops. Oh no.
It says like error in type and gives you error and gives you original value. So you can compose out of it whatever error message you want.
That's cool. It's very cool. Scroll up there. Yeah, it's really neat. Let's see. ARGS
Feels like it's close.
feels like it's what?
I said it feels like it's close.
Yeah. So here's some like sequence schemas, it looks like.
Yeah, I think it's for positional arguments. That part is pretty complex in README.
Okay. So what does this mean? So
0 or more.
0 or more cat n.
The N stands for named.
What's the name of your cat?
No, I think that the different parts inside the concatenation,
Yeah,
inside the sequence
concatenation
have
sequence.
names.
Okay.
Yeah, I think.
So this would be
It's like property and value.
property value.
And
So
those are being concatenated. And the values can either be string or Boolean.
yeah. Okay. Cool. So this is a property, which is a string. This is a
Yeah.
string value
Yeah.
property. This is Boolean value property.
Right.
String value. Cool.
So if you take one of them out, it's invalid because it's an odd number.
Yes.
Wow.
Yeah.
So these hyphens, these minus signs don't signify anything to the validation.
True.
do they?
Yeah. I can delete these, and this will still be. Although we could probably add something to
Yeah.
this thing here to indicate that it has to be.
Start with a
Or you can put and.
Oh, and
With the vector notation at least.
this and
No, I think the and goes where the string is inside the prop. Yeah.
oh, gotcha. And string, and then something.
In the function,
This is starts with.
fn keyword, and then put a function. Starts with.
So yeah, I screwed up my.
Just make it a function. Now it's just a call to wrap it in a function and argument.
Let's try to make it fair. Actually, this isn't compiling correctly. I think this is a little bit. Let's see if we can put this on different lines. We can make it a little bit more readable. So this one.
Thank you for that. I was having a hard time too.
Yeah. So string and function. And then property or value, which is alternative string or Boolean. Okay. Did I have?
I'm guessing that colon FN is incorrect in that position because string question mark is a Boolean function, and we want to give another Boolean function, and I'm imagining it does not need to be delimited with brackets colon FN.
Okay, so it's.
So we do no. I think it's correct because you just do two schemas and we define a schema. So you can either define it as a
This is
string.
considered a schema, right? So
Yeah.
I think there was another example here. Oh yeah, colon FN. Here's a colon FN, and then this. Here's an example of the colon FN. We can just copy, I guess, and then see if that. Oops. Oh, I lost something formatting. But
Oh man.
we'll fix it. String is. Oops. Oh my goodness, that doesn't look right at all.
Man, that auto indexing is really fighting with you.
Yeah, it really is. Yeah, it doesn't like that either. The function has to be inside. Right, so something like this. Yeah, okay. All right, so it's executing that thing, which is fine. So error message. All right, forget the error message for now. Let's just remove this. And we'll just say function. Oh, it's getting out keys X and Y. So I don't think we need keys. Guess
Maybe just passing the regular string value, right?
Yeah, so I think what we want, this is, assuming this is the value, we'll just say S.
Starts with question mark.
That thing you just looked at. That's cool.
Yeah, so it's a Clojure string. I don't think it's,
Yeah, I think
it is like the full namespace.
yeah, there we go. Okay, and then if we delete it, super cool. And now we could actually add a message. Yeah, there we go.
Nice.
Oh, that's really cool. There's one more example here, which is hiccup. So we can take a look at that. Oh, okay. So this is hiccup. Or, oh, okay, we had cat n, now we have or n. And it's either a node or a primitive. The node, and then we have cat n inside here. Node can either be something with a name, which is a keyword, like this. Props, which is question mark, so this is optional, I guess. Optional props, which is a map of keyword in any, and then children, which is 0 or more, and then it's recursively referring to hiccup. So in this case, we have a node with props, with some random value, with any value, and then children is going to be a node, and then with some primitive. This is not a vector, so it would probably be matching this one, I guess. And this is going to be or. It's either going to be nil, Boolean, number, or text. So in this case, I guess it's text. We also do like, and you can have any number of children. So if I say false, this is also fine, or 3. But if we take out one of these things, say like Boolean is actually not legal. Oh, interesting. Look at the error message here.
Wow.
Yeah, it gives you the nesting. Invalid type should be nil, should be a number, should be string. Null number or string here. That's cool. Pretty neat.
There is a story about this sample. It comes from my project.
Oh, really?
Yeah. So because I wrote minimalist when there was no sequences anymore, not yet, I mean, and it was for front-end library, and my goal was to parse a recursive data structure, which looks like hiccup. So when I wrote the library minimalist, I wrote this sample on the front page, and later Hitomi asked me if you could just put it there. And I say yes. So hello world of data. It was me typing.
That's awesome. It's very cool. Yeah, it's a nice, I mean, it's also kind of neat how like compact this schema is, you know, and you can do like really nice, arbitrary kind of like HTML pickup kind of stuff just with this simple recursive schema. It's pretty cool.
Yeah, it's really cool because we haven't even looked into many use cases that they have probably covered like 25%. Like I really like spell checking in the keys. So like if you go to README and go to like the spell check, something like that.
Oh yeah, check this out.
So like the idea here that you have like a scheme defined, and you can, and because it's data, you can make it a closed schema. So you like transform it, and then you do explain and like do spell checking, and you can say, okay, it's a required key, should be spelled straight, and so on. So just in runtime, you can take your base schema, transform it for your particular validation, and like drop it. It's like very good.
Oh my gosh.
And then another really cool is like they try to infer schema. So like you can put the samples for them and it will try to build a schema for you.
Oh, okay.
Oh, that's pure magic.
Yes, this is not total magic. It has its limits.
That's pretty neat though. So you can take arbitrary data and then just like try to do this, and then you have a starting point for your schema then.
So there is a small problem on the hiccup sample. If you want to go back to the tab, basically the place where there is a cat n, it says that there is it's a sequence of concatenated other sequences, but it does not say anything about the type of the sequence. It could be inside a vector or just a list. So
That's
that if you try the value and replace the vector by something like something else like a Lisp, and then it works. And this is not valid hiccup. So as an exercise, if you want to try to fix the schema.
Okay, so let's see, what would we do here? We'd have to actually, what would you do for this? Would you have a validator at the node level, something here, to say that the value has to be? Oh, actually, you could you say?
Yeah, I think that could work, and then say it's a vector. In fact, I don't know if hiccup has to have a vector there. I only saw vectors. Should be, I think.
Yeah, so we could try doing.
Oh, maybe you can just write a vector with a question mark.
Oh, good point. Yeah, look at that. And then if we actually change this back to a vector,
okay.
it passes.
Good job.
Yeah, good job.
Simple fix. It's pretty good.
Also really like that you can parse values using schemas. Like if you go to parsing values in README.
Oh, okay.
So like, for example, the same script parsing values. Like you can do this prop server value and so on, like pretty much make a map key out of it.
Yeah. In schema, they in Clojure spec, they call this they have different verb for it, I guess. But yeah, that's really cool. It's pretty fast too. I mean, like I think, yeah, there was a blog post, I think, Darby, you were mentioning that where they're talking about how they're trying to optimize the performance of this too. Because there's a bunch of different use cases for schema. I mean, that looks like they covered here too. One is validating. The other one is parsing like this, which is really cool. And then there's also like test generation, all this kind of stuff that you can leverage your schema for, which is really neat.
Then I guess you can transform all of this schema into Swagger and then use like document generator from Swagger and like do online documentation and stuff.
Yeah, yeah. So like each one of these pages also has, right. Well, actually, here's the inferred schema from value, which isn't the same as this because it's basically just inferring like specifically what's here. But that's interesting. Sample values from inferred schema, and then wait, did I pass it? Yeah, transform schema here, right? So here's Swagger, which is really cool.
That's a bad example because you just have
Yeah,
hiccup.
that's true. But I mean, like if we take a look at one of the other ones, like there's probably some more interesting ones. Yeah, here's a Swagger schema.
Just Swagger schema.
It's
Swagger.
Swagger, like for like REST APIs and stuff like that. If you have a REST server that well, actually, let's see. I think they call it Open API now.
It's Open
Yeah.
API now.
Yeah, but it's basically if you're doing an API, you can basically specify a Swagger schema. Actually, yeah. And then it'll automatically generate tooling for you so that people can basically, there's like some sort of,
So you can generate documentation, you can run like tests on it, have to generate values.
yeah.
Not a
So,
schema format, but it also has tons of functionality that is widely adopted.
so the nice thing about Malli being able to transform into Swagger is you can kind of immediately take advantage of all the tooling around Swagger or Open API. I mean, there was like a API editor, something like that. Swagger editor, here we go. So you can say, I can specify a big old Swagger schema, and then, there's all this kind of tooling where you can kind of validate things that are coming into your endpoint, automatically generate error messages, and then like, create and all that kind of thing. So a lot of that's sort of like built into a lot of these web servers and stuff. So
Is it in the client as well?
you can use it in the client as well.
Yeah. There's a client called Martian, a Clojure client called Martian. Yeah. Yeah. That's it. So, yeah.
Yeah, automatically validating.
So you can see that, yeah, right where you are there. You give it an Open API specification, and then from there you can do a response for which does the call and the return value and does all the mappings back and forth, so you get back and like an Eden.
Oh wow, that's cool.
And if you scroll down a bit, I think you should see the explore ones also. Scroll.
And presumably,
yeah, that right there. So you can like explore that M once you have it, so you can see what methods you can run on it.
Oh, that's really cool. And presumably it'll like do all the validation too. Like if you do something that is illegal, it'll warn you that you actually need to call. That's cool.
Yeah, I've actually been working on with Martian a little bit in the last week or so, and it's not quite. It's got some bugs with Open API. The Swagger stuff seems to work pretty well, but with Open API 3, it's got a few problems.
Yeah, I guess the name changed with version 3. I guess Swagger, like Open API 2 is, or Swagger is Open API 2 or something like that, right?
Correct.
Or,
yes. And now there's just there's an Open API 3.0 was there. Now there's a 3.1, and many tools have not gotten compatible with 3.1.
oh, okay.
So, there's one really interesting thing where in Open API 3.1 is actually quite different from Open API 3.0.
Oh, no.
And they, when they started doing it, they said that they were going to do semantic versioning, and so there's a big sort of discussion and all saying, should we make it Open API 4.0? And eventually they decided to give up on the SEMVer and go to 3.1.
Yeah, that's funny. Yeah. So I guess Malli is generating Swagger, which means it's generating Open API 2.0, I guess. Yeah, Swagger 2. It's like Swagger 2 schema, which sounds like it's more widely supported.
If you use Reatish, or however you pronounce that, they're also from Metosin, to do your routing. You can specify Malli schemas, and you can do spec and schema also. But when you do that, then it automatically generates pluggable coercion is the link if you're looking for it there. But yeah, it automatically generates the Swagger. We are using that. It's pretty cool.
Well, looks like
not have to manually make the Swagger.
Oh, okay, yeah, that's cool. So if you have Swagger, I guess you can use this, but if you have Malli, you don't have to do the conversion. You can just use this directly. That's cool.
Yeah, I think the coercion is the validation side, and then the API docs is the one that actually renders the page that has the pretty, you can navigate the different routes and stuff.
Yeah, I think that's the Swagger UI.
Oh, this one?
Yeah.
Oh, there it is. You're right.
Yeah.
You're right.
Okay. Swagger UI. No, I think that's what we were looking at before. Basically, this editor thingy. Yeah, this is the thing. Cool. What else is in Malli that we didn't touch on that we want to look at? CLJ condo. That's interesting. Oh, you can generate CLJ condo configuration. For linting.
Is there a visualization there?
Where? Say again?
Visualization?
Visualizing schemas. Oh, yeah, look at that.
Ah, cool.
Oh, yeah.
Graphics.
Oh, yeah, we saw that here, right? So there's Swagger schema, and then there's dot stuff, so you can generate this graph, there's visualizations. Wow.
It was a little object oriented.
Yeah, UML diagrams and whatnot. But I mean, it just,
UML. It's UML.
Brings back bad memories.
Yeah, I know.
Look, plant UML.
Oh yeah, literally. Look at this.
Oh my.
Oh my gosh. Oh man, this brings out horrible memories.
But
Export to flowcharts as well.
export to what?
Flowcharts.
Flowcharts? I don't know.
How about assembly language?
Well, yeah. Yeah, performance. This is just some performance bench, like transformation performance. Oh, I guess there's some notes here about like actual performance. Idiomatic Clojure, is actually faster for this kind of thing. Clojure spec and thematic schema. So Clojure spec is way slower, and thematic schema is even slower than that. So we're talking 39 nanoseconds versus order of magnitude higher. For these other ones, transformation performance. Whoa, it's yeah. Again, order of magnitude is smaller. Spec is really fast here though. The transformation looks like. Oh no, this is microsecond and this is not nanosecond, so it's still order of magnitude. So yeah, fast, very good. Speed is a feature. Parsing looks like it's a bit slower, but still like low microsecond range. Pretty good. Yeah, this is really. I kind of wish the README was like not just one huge page, but actually like pointing out this table of contents. I've never seen this before, but that's super useful.
I think it works in every repository.
Yeah, I never noticed it before. That's very cool. Structuring. I mean, like for you guys that have been using Malli, I mean, what are your are there things here that you're not familiar with that you want to cover, or the favorite things that you use all the time that you want to call out? Or I mean, what are your thoughts, pros and cons after having used it?
I mostly use it for validation, so my use case is simple. I don't go into any like complex things. But yeah, like for what I do, I just have this objects like where you can have key and describe Malli schema for that key, and then I put everything in the global registry, and then I have when I generate a form in Clojure script, I just say the name of the field, and it automatically hooks up the validation from Malli and errors and stuff, and just like really easy for me. Like, mix and match in form multiple different keys, and it automatically validates all the stuff.
So like when you do validation in your system, do you do it like everywhere within I mean like within
like when I generate like a front-end form, for example, like address form, I want to fill out fields. So like I just put a field name, like my namespace keyword, and it's like a global registry of what this namespace keyword means, and it's a Malli schema. So I don't write any extra validation code, just to use this Malli. This on every change in the value of that form, it just does a validation check. Goes find this Malli schema, validates every field and generates errors, so like passes validation. For me, it's very easy. I don't need to think about it, and like all this libraries in JavaScript where you have to do like some custom validation. I just avoid all of that because usually form libraries are pretty bad with their API.
Yeah.
It's just like pain in the ass because everything wants their own stuff and you can't reuse it outside of that form. So yeah. I like that Malli can help solve this.
So I guess one question I have is like, when you're, I mean, it obviously makes a ton of sense, like form input time or, API, when you're actually like at the edge, when you're actually like, transferring data between systems to be able to validate it. But even within, like if you have a large amount of logic inside of your system,
and you're passing around large data structures. One of the things that you know, like that I think is kind of useful is to be able to sort of like, instead of kind of like, you know, we don't have I mean, you can do type hints, I guess, for like primitive values and stuff like that, but to be able to like annotate your arguments and be able to say like this argument to my function is actually corresponds to this particular schema. Is that something you do too, or?
Like my projects are small, I don't do it, but if you search for function schemas in README, they allow it to do something similar here. So you can, yeah, working with functions. You pretty much do the same that spec does. So you can describe the arguments, what the outcome may be, and then do some generative testing for it. So that's, I've never touched it, but I've seen that they can do it.
Okay. I see. Generative testing. So this is defining the schema. I guess
I guess like what they do is similar what test check does, where you can just, if you describe the arguments and return type, it will just generate a bunch of random values and see if your function returns expected results. So that's kind of what they mean by generative testing.
yeah. I guess my I mean, I haven't used it for this either, but like sometimes in you know, some of my my code, like for instance, if I'm writing, you know, like, let's say we're writing some you know, complex function or whatever, and it has like some, you know, big arg or whatever, and I want to be able to indicate, like, you know, basically indicate what the type of this thing is. I guess you could use metadata too, maybe just to say like, you know, args, and then maybe have a map for, you know, or refers to like some Malli schema or something like that. I'm just wondering, like, it might be useful as a documentation tool for your function, and then maybe this isn't exactly like a function schema, or maybe you could associate you could put the function schema here, maybe. And then this could be like some function schema.
I think there is some facility for doing that, for validating the function there. One thing I like about schema is that you can basically do like schema, like s/defen, and it'll do a validated, it's like a validated version where you can either validate the inputs or the outputs.
Right, for schema, you can definitely do that. Yeah. Is there a way to do that in Malli too? Is that here, or is it somewhere else?
I think it might be via metadata.
I think there's like a Malli instrument, an extra library.
Is this it? No, there's an mx-defen. What was it? Schema hints. Oh no, this is different.
Look for instrumentation in the README, and there's a link. Oh, maybe you just had that.
Here.
Oh, defen instrumentation. Is this? Let's see. Instrumentation.
Got it.
Oh, is this literally what we're looking at? Instrumentation. Instrumentation.
This parallels what Clojure spec does.
Okay. So with the like s-defen or whatever in Clojure spec. Nice.
If you scroll down a little bit, there's something about functions specifically.
Functions. What?
Yeah, keep going. Defen schemas.
This one. Okay, 3 ways to add function bars. So there's a function schema annotation, function schema metadata, and then function inline schemas. Wow, a lot of options.
If you want to go down to the table of contents and go to value generation.
value generation? I don't see it.
Back in the README, I think.
In the
Oh,
README. In
oh,
the
sorry.
README.
Is this the README? I can't see that. README.
Oh, so it's not all one page.
No.
It spans files.
Any
But yeah, the thing I wanted to show was the Gen F map that we ran into earlier.
yeah.
Yeah, it's you just no, you went down too much.
Oops, sorry.
Stop. Yeah. I think it's yeah,
Oh,
yeah,
okay.
it's yeah, there. That's a good example where the generator is string question mark, and then you have a function that is applied to the result of the generator. That's what fmap does in general.
Oh, yes, yes, it modifies the base generator.
Correct. Yes, it makes a new generator which takes a previous generator and applies a function to it.
So it's like a let kind of.
Cool, cool.
Yes.
It's very cool. It's a very big topic, but also like it's actually, I don't know, I'm impressed. I mean, this really, like, they cover a lot of ground, and they really show off like how much leverage you can get by defining schemas.
The breadth of functionality that is here is amazing. Like, I don't even know if I'd be able to use it all. Like, I might just use the validation to start, but it's just amazing how much stuff there is.
Yeah.
Well, nobody uses all of Photoshop either.
That's true. But I figure like everybody uses different parts, so like you wind up with a big one. So that's very cool. I guess, and there's separate namespaces too. So like generator stuff is separate. Yeah. Well, I definitely want to play with this more.
I'd be interested to see how I would implement tree generation.
Hmm.
Done it in Clojure spec, and it's kind of hairy.
Cool. I mean, we got about 10 minutes left. I don't know, like what else should we look at before we close? I feel like we covered a lot of ground.
Yeah.
What else is in it?
Yeah, I agree.
What else is in the table of contents?
Wow.
A lot more.
Pick one.
Schema transformation?
Oh my. Schema walker. Fantastic.
Yeah.
I'll bet there's a zipper in there.
Wouldn't doubt it. Well, we talked about the JSON schema and the other stuff already. Transform schemas into maps. I mean, yeah. It's the
Okay, but what's the motivation for transforming a schema?
well, I guess like JSON schema and Swagger too, like other schema representations. I guess that's how you do them.
Oh, so it's mostly a format deal.
I think so.
Okay.
Yeah, I mean, also if you want to use other tools like if you want to use the Swagger tools that are already developed for Swagger. I'm wondering if is there an open API thing, or is that the same as Swagger? There's Swagger 2 and Swagger, and I'm wondering whether the Swagger is the same as Open API then.
Oh, so I see Swagger 2. Where's the Swagger one? Is there a different
I think it's below.
below?
Just
Keep going. Custom.
no, I thought I saw it while you were scrolling, but I can't. I don't see it now.
Oh, okay.
So
No,
I
think
was
we've gone
wondering,
past.
if rather than transforming into other formats for other tools to use, is there a use case for actually modifying this?
There's like, if you go back to an example with spell checking, they take like a normal schema and make it closed, so you can check for like typos in keys.
Oh yeah.
So they like take a schema, they transform it to a closed schema, they add some explain, and yeah, also explain is just a call to with value, but then you can do spell checking, and it just with this simple change of making it close, it can verify that some keys are like matching and some of them not, and do like the how much it covers with a key if it's a typo. So it's pretty cool thing what they does.
So this is like a decorator. This is nice.
Yeah. So and like for example, if you want to do like you have a schema and you use like human errors, so you use this schema to validate internally, and then if you need to show it to customer, you just like add this humanize or like add some extra like languages. Probably you want like localization or something like that you need. So many things where you can just in runtime change it and get a little bit better for your particular use case.
Maybe. Yeah, the fact that it's based on data, it's like it just makes it more accessible, I feel like, than spec, because we can, yeah, this is really neat.
I've been using Honey SQL for generating SQL statements, and because it's just data, the amount of transformations you can do, you can have like a base select, and you can add like other, you can combine it with other things, and then have modifications like functions like that just change one part, and so you can chain them together in like a declarative way like that. But under the hood, the cool thing is it's not some magic thing. It's at any point in time you can just print the data structure out and see what it did to it. And so it's very plain and very harmless. Data never hurts you.
Yeah, I've done the same thing for like
Never
Firebase
gives you
API.
up, never.
Yeah, so with Firebase API, I also have this like data vectors instead of chaining function calls, and then it just can compose any query, and like in one place, I just change a JavaScript object and send it over. But my language has simplified so much after this instead of like interacting with their API.
Oh, value transformation is interesting too. Look at this. That's interesting. So actually, I don't know if Malli covers this case, but there's a separate library that I used before for like binary data encoding and decoding, where you kind of provide like a bitstream binary format, and then you can basically encode things into bits at that level. But having schema for that was kind of useful too. And I'd be a little bit surprised if Malli actually goes that far, but and this just made me think of that. What was it called? Aleph or something like that? Or something that was part of Aleph.
Yeah, byte streams or something, one of the libraries that you could use over there. Yeah,
Right.
I've gotten close to that one too.
Yeah.
Well, have we had enough Malli for tonight?
Yeah, I think we can call it.
Thank you so much, Edwin.
Thank
driving.
you.
I really appreciate it.
Oh yeah, no problem. Stop sharing.
Great.
This was fun. I mean, yeah, I've been meaning to look into Malli for a while. It's always doing it in this format. I think is more enlightening and more fun. I think than just like reading myself. So, thank you all too.
Thank you so much.
Okay.
Yeah, if anybody has any suggestions for a library for February.
Maybe we should go down the Metosin stack of libraries.
Sure.
Oh, I have a
We'll
suggestion.
just have a challenge with the pronunciation of the words. So.
Yeah,
I have a suggestion for a library.
go for it. What is it?
I'm putting it in chat right now. That's on GitHub. It's railway-oriented programming.
What?
Wow.
Look that up too. It's very cool. I'm using it in my project. Basically, you start from the principle that you never throw an error. You can return an exception info, and you're chaining functions, and you have keywords or functions in flow such as then and else. And when a function is enclosed within a then, it only gets executed if it receives a non-exception from the previous function. And else only gets executed if it does receive, if what it receives is an exception from the previous function.
That's interesting. What are you using it for?
I'm using it for just about everything in a library that I've been building for my company for the last 6 months or more. And I'm trying to promote the rest of the team to use it in the main app itself.
So I think you just volunteered to lead the next Clojure.
Oh, no, okay. All right. Yeah, sure. Yeah, I just need to verify that I can show some of our code that I've written, and that'll make it much easier to talk about. And we'll be touching
yeah,
on,
definitely want to explore.
we'll be touching on zippers as well, just by by necessity. So when is the next meetup?
Second Wednesday of every month.
Second Wednesday. So February 2, February 9. Great. We'll talk.
Alan, this is a random question, but like, how long have you been in SF? Have you ever lived anywhere else?
I'm from New York originally.
Ah, okay. Because I mean, you look familiar. Did you go to the New York Lisp meetup before?
I have been there.
I think I remember you from there.
Oh, could be, could be.
Oh wow. Okay.
I remember. I think the first time I went there, it was because what's his name? I'm sorry, I can't think of it right now. But, Hugh, who spells his name H-U-Y, I believe. He was talking about a tool for aggregating tweets and references and things like that, that reference certain topics. And I believe he wrote it in Clojure, although his main deal is Haskell. It was at that meetup. It was at least 5 years ago, maybe more. And It was at that meetup where the list meetup where I asked the question, please don't take this the wrong way, but why would you use any other Lisp besides Clojure? And he told me why.
Cool. Anyway, small world. That's pretty neat. All right, I'm gonna head out, but it was good meeting you all.
Same here, same here.
Great to
Thank
see you
you.
all. Happy
Bye.
January.
Good January.
Yeah, Happy New Year.
Bye.
Bye.